Today's lesson is order of operations and like terms vocabulary. So get out your notes, notebook. Let's take some notes. Okay, so these notes need to be in your notebook. First, we have order of operations, which this is review for you. You should have had this before. The order of operations is the order in which you simplify an expression. And sometimes we refer to this as PEMDAS. PEMDAS is an acronym for order of operations. It means parentheses, exponents, multiply, divide, add, subtract. All right, there are a few things that you need to remember with order of operations. It's very important that we do order of operations properly so that we all get the same answer. So first of all, when you have parentheses, you must simplify from the inside out. And I'll show you what that means. So simplify from the inside out. If you have an expression with both addition and subtraction, or with multiplication and division, you simplify in order from left to right. So what I mean by that is, you've seen this before, PEMDAS. And I write PEMDAS like this so that you remember that you do the parentheses, then you do the exponent, and when you multiply and divide, you go from left to right, and adding and subtracting from left to right. And I'll show you what that means as well. Okay, here, more notes right down here. The expression n to the third means n times n times n, where n is the base and the 3 is the exponent. It is either read n to the third power, or we can call it n cubed. All right, make sure those are in your notes. Let's move on. Okay, here we have some examples, starting with number 1. Parentheses you want to do first, and you need to write the problem and show work on these. So write down the whole problem, work it, and show the work. This is how you're going to show work. So 5 plus 3 is 8. Then you're going to multiply and divide. There's no exponent, so then you would divide by 2. 8 divided by 2 is 4. And then you would add 2, and that was going to give you 6. All right, number 2, here you have parentheses and you have exponents inside of the parentheses. So because you have the exponents inside of the parentheses, you want to do those first. So 2 to the third power is 8. 2 times 2 times 2. Plus 4 times 4, which is 16. And that's inside of parentheses, so that you must add those together and then multiply. So 8 plus 16, I believe, is 24. So then 3 times 24. So 3 times 24 equals 72. All right, next. All right, you want to look at it. First, you have division there. You have division, multiply, multiply, and divide. And if you'll notice in PEMDAS, you have to multiply and divide from left to right. So we're just going to go from the left to the right and work the problem. So this is how we show work. 20 divided by 4 is 5. 5 times 5 is 25. And then times 2, that's going to give me 50. And then divided by 10. So 50 divided by 10 is 5. So that's a quick and easy way to show work. All right, example 4. Here you can see we have a fraction bar here. So we have a fraction, and that tells me that I have to do the top part first, and then I'll do the bottom, and then I'm going to divide the top by the bottom at the end, and then subtract 4. So let's start with the top. So I have parentheses here in this particular problem. The parentheses doesn't really mean anything. It's just separating the 4 and the 6 and showing that that's multiplication. So I'm going to do the exponent first. So I'd get 64 minus, and then I have to multiply the 6 and the 4 together to get 24. Then on the bottom, I just get a 10, and I still have the minus 4. So I simplify the top. 64 minus 24 would be 40. And 40 divided by 10 minus 4. So 4 minus 4 equals 0. So make sure you do the top of the fraction, the bottom of the fraction, and then you're going to divide. All right, number 5. here we have a bracket with some exponents, with an exponent and some parentheses. So it says to do parentheses first. Within the parentheses, we are supposed to work from the innermost parentheses out. So the innermost parentheses would be here. So the exponent is on the outside, so you're going to do that after you do the inside of the parentheses. So we have 2, then we have 3 plus 2 times 2, which is 4, and then 4 squared. Then I do the square, so I do 2 times 3 plus 16. Then, of course, I have to add this 3 and the 16, so that's 19. So it'd be 2 times 19, which is, I believe, 38. And that's going to be your answer. So we'll practice those in class. All right, let's move on. Okay, write these notes down in your notebook. Terms. Terms are the parts of an expression that are separated by an addition or subtraction sign. So here we have this expression, and we have 1, 2, 3 terms. So remember, they are separated by an addition or a subtraction sign. Then we want to learn the word coefficient. The coefficient is the number part of a term with a variable. So it's the number with a variable. So the coefficient here would be a 3 because it's with the x, and then a -5 or a -5 is with this x. Now this subtraction sign becomes part of that 5, making it a -5. So you can look at that as minus a +5, or when we're identifying coefficients in terms, we just call that a -5. Okay, let's move on. Here are some more definitions that you need to have. A constant term is a term that is a number only. There are no variables. So in this problem, the 4, the +4, is a constant term. And we identify and use that plus sign that makes that 4 positive. We'll talk about that a little bit more. Okay, like terms. Terms that have the exact same variables with the exact same exponents. And you guys had a little bit of this last year. So like terms are important. They have to have the exact same variable and the exact same exponent. So in this expression, the 3x and the -5x are like terms because they both have an x. In this particular problem or expression, we have a squared and we have another a squared. So this is a like term and this is a like term. But a cubed is not like. It has to have the exact same variable and the exact same exponent. The b squared wouldn't work even though it has the exponent of 2. It's a different letter. So you need to learn to identify like terms. So this would be a squared and -2a squared. All right, we want to identify the terms, the like terms, the coefficients, and the constant terms of this given expression. And then we're going to simplify the expression. So the terms of example 6 here, let me get my pen. The terms are 10, and then 3a squared, and then -4, because that negative sign goes in front of it, and then -6a squared. So when you identify the terms, you use the sign in front of it to say whether it's positive or negative. If you have questions about that, make sure you note that so that you can ask me in class. All right, the coefficients, remember, are the letters that are with the variables. So we look over here and we can see that the coefficient is 3 right here with the a squared and then a -6. So again, that 6 takes that minus sign and it makes it negative. All right, like terms. What are the like terms? Well, we've got a squared and a squared, so 3 positive 3a squared and -6a squared. And then the constant, remember, are the numbers by themselves. So the numbers here by themselves would be a 10 and then a -4. Those are the constant terms. Simplified. So now we're going to simplify. That means we're going to combine like terms. So we have like terms, we said, right here, the variables, right here. So we're going to combine those together. So we have a positive 3a squared and a negative 6a squared. So positive 3 and negative 6, you add those together. You add the coefficients, but you keep the variable. So we're going to add the coefficients, 3 plus negative 6, get negative 3a squared. And then we're going to combine the constant terms. So here we have a 10 plus a negative 4, which makes positive 6. The other way we can write this is we can move these terms around, and we could put the positive 6 in front and the negative 3a squared behind. And then the negative 3a squared looks like subtraction. All right, again, if you have questions, put a little question mark. Be sure to ask me in class. All right, these are our last two examples. We're going to simplify the expression by combining like terms. So I look at the first one and I see which one of these are alike. Now I'll use color on this. So I'm going to put a box around the x's that are alike. So that's a 2x. And notice that I put the box around the plus sign in front of the 8x because that tells me that that is positive 8. And then I'm going to take a different color and I'm going to put a circle around the constant terms that are alike. So a negative 5 and a negative 3. And again, I put a circle around the minus sign that's in front of the 5 and a minus sign in front of the 3 because now I have a negative 5 and a negative 3 that I'm going to combine. So now if I simplify that, I would get 2x plus 8x makes 10x. And it's not x squared, it's just x. I just add the coefficients together. And then a negative 5 plus a negative 3 makes minus 8. So this is the simplified version. I could also rewrite that and put the 8, the negative 8 in front, and the positive 10x behind. So both of these would be correct. All right, let's look at example 8, our last example. I'm going to circle the constants that are alike. I have a positive 2 here, and then I have a positive 6 there. So if I add those together, I would get 10, and then I'm going to get a different color. And I'm going to put a box around the xy squared. Notice that I have a positive 3xy squared, and I have a negative 4xy squared. So now I'm going to put everything together. 2 plus 6 makes 10. And then 3x squared minus 4x squared, you combine the coefficients and you leave the variables the same. So the variables will stay the same, xy squared, but 3 minus 4 is negative 1. Now you can write the negative 1 or you can just leave it off. So 3 ways this can look. You can leave it like this, or you can just do 10 minus xy squared, that's the same. Or you could take the negative 1xy squared in front and then put plus 10 for the 10 because it's positive. Okay, write down any questions that you have from this video. Be sure to ask me when you come to class, and have a great day.